G'day, science lovers. Imagine this. You've just rolled out of bed on a beautiful Monday morning. The birds are chirping, you've got your toast and Vegemite ready, and you're about to tackle the day. Everything seems perfectly normal, right as rain. You might be thinking about your commute to work, what to have for lunch, or that pesky email you forgot to answer. But unbeknownst to you, something absolutely catastrophic, something properly world-ending, has already happened. Our magnificent, life-giving star, the Sun, has just gone belly up. It has exploded in a final, glorious supernova, unleashing more energy in a single moment than it has in its entire 4.6 billion-year lifetime. You wouldn't know it yet, though, not a sausage. You'd still be enjoying your brekkie, blissfully unaware of the cosmic kerfuffle unfolding 150 million kilometers away. You see, the universe has a built-in delay. So let's get down to the nitty-gritty. Why 8 minutes? It all comes down to a bit of simple cosmic mathematics, so don't you worry, it's not rocket science. Well, actually it is. The distance between the Earth and the Sun isn't fixed. It varies a bit as we travel along our elliptical orbit. On average, though, we're about 150 million kilometers away from our fiery friend. Light, our universe's ultimate speedster, travels at roughly 300,000 kilometers every single second. So if you divide the distance, 150 million kilometers, by the speed, 300,000 kilometers per second, you get 500 seconds. And how many minutes is 500 seconds? You beauty. It's about 8 minutes and 20 seconds. It's that simple. This delay isn't just for light. It applies to everything that travels from the Sun to us, including gravity. That's a real mind-bender, isn't it? According to Einstein's theory of general relativity, gravity isn't some mysterious force that pulls things instantly across space. Instead, it's a curvature in the fabric of space-time itself, caused by massive objects like the Sun. This gravity wave propagates outwards at the speed of light. So if the Sun were to suddenly vanish, Earth would continue to orbit the empty space where the Sun used to be for a full 8 minutes and 20 seconds. We'd be orbiting a ghost, held in place by phantom gravity, before our planet would suddenly fly off into the void in a straight line, like a stone released from a slingshot. Exactly 8 minutes and 20 seconds after the Sun's explosive demise, the first sign would arrive, and it would be spectacular. The sky would erupt. Forget your average sunset. This would be a light show to end all light shows. The initial wave of energy from the supernova, a flood of high-energy photons like X-rays and gamma rays, would slam into our upper atmosphere. These particles would interact with the nitrogen and oxygen atoms, causing them to glow with an intensity that would make the aurora borealis look like a dim nightlight. The entire sky, from horizon to horizon, would be painted with shimmering otherworldly curtains of red, green, and purple light, brighter than a full moon. It would be terrifyingly beautiful. At the same time, another dramatic event would unfold. The Sun itself would appear to swell in the sky. As the shock wave of the explosion expanded outwards, the disk of the Sun we see would seem to grow larger and brighter every second. It would be like watching a billion nuclear bombs going off at once, but in glorious, silent, slow motion. Anyone unlucky enough to be looking directly at it would be instantly blinded. Even a quick glance would be enough to cause permanent eye damage. The sheer brightness would be unimaginable, turning night into a blinding, surreal day for the side of the Earth facing the blast. The heat flash would be instantaneous and ferocious. This initial burst of radiation would be the harbinger of doom. It would be a cosmic sledgehammer, immediately frying any satellites in its path. Our global communication network, GPS, television, internet, mobile phones, would be wiped out in a flash. One moment you'd be trying to call your loved ones to ask what on earth is happening to the sky, and the next, your phone would be a dead brick. After the initial blinding flash and the beautiful deadly light show, the main event would arrive. The light from the supernova would fade, and then, nothing. Utter, absolute darkness. The Sun, our constant, reliable source of light, would be gone. The sky would turn blacker than the blackest ink. It wouldn't be like a normal night, where you can still see the faint glow of the Milky Way, or the familiar twinkle of the stars. The dust and debris cloud from the Sun's explosion would now be blocking our view of the rest of the universe. We would be enveloped in a profound, suffocating darkness, a cosmic blanket thrown over our entire world. It would be a blackness deeper than any cave, an absence of light so complete it would be disorienting. The psychological impact would be immediate and devastating. Humans are visual creatures. We rely on light to navigate our world and to feel safe. Plunging the entire planet into perpetual absolute darkness would trigger a primal fear in every single person. The initial awe at the light show would curdle into sheer panic. People would be fumbling for torches, for candles, for any source of light to push back against the oppressive dark. The world's power grids, already crippled by the initial radiation blast, would likely fail completely, leaving cities and towns as dark as the deepest wilderness. The familiar glow of civilization would be extinguished, leaving only the sounds of rising panic in the gloom. Animals, too, would be thrown into chaos. Their lives are dictated by the daily rhythm of sunrise and sunset. Nocturnal animals might emerge, confused by the sudden night, while diurnal creatures would be utterly lost. With the sun's light and heat gone, the earth would start cooling down, and it would happen surprisingly fast. Think of our planet as a giant hot water bottle that's just been taken out from under the blankets. Without its constant source of warmth, it immediately starts radiating its heat away into the cold, empty void of space. Scientists reckon that the average global surface temperature, which is currently a comfy 15 degrees Celsius, would drop to around freezing 0 degrees Celsius within the first week. By the end of the first year, it would have plummeted to a bone-chilling minus 73 degrees Celsius. That's even colder than the coldest winter day ever recorded in Antarctica. The first thing we'd notice is the frost. Within hours of the sun disappearing, a delicate layer of frost would begin to form on every surface, even in the hottest deserts. The drop in temperature would be relentless. The first day would feel like a crisp autumn evening. The second day would feel like a harsh winter morning. By the third day, ponds, lakes, and rivers would start to freeze over, starting from the surface and freezing downwards. The weather systems we know would just cease to exist. Without the sun's energy to drive them, the winds would die down, the clouds would dissipate, and the rain would stop. The world would become eerily still and silent, under a perpetually black sky. The oceans, which are our planet's massive heat reservoirs, would put up a valiant fight against the cold. They hold an incredible amount of thermal energy, and it would take much longer for them to freeze completely. A thick crust of ice, maybe several meters thick, would form on the surface within the first year. This ice layer would actually act as an insulator, protecting the liquid water in the deep ocean from the savage cold of the surface. Down in the crushing dark of the abyss, near geothermal vents on the ocean floor, life could potentially cling on for thousands, maybe even millions of years, completely unaware that the world above has become an ice ball. This planetary deep freeze would transform the very face of our world. Snow would begin to fall, and without any sun to melt it, it would never stop accumulating. Glaciers would start to form, not just at the poles, but everywhere. Entire continents would be buried under a deepening blanket of ice and snow. The end of the sun would mean the end of photosynthesis, and that's a real bummer for pretty much every living thing on the surface. Photosynthesis is the magic trick that plants use to turn sunlight, water, and carbon dioxide into energy and oxygen. It's the absolute foundation of most of the food chains on our planet. Without sunlight, this process would grind to a halt instantly. The world's plants, from the mightiest redwood trees to the humblest blades of grass, would begin to die. Within a few days or weeks, the planet's green lungs would wither and turn brown, starved of their essential energy source. The death of the plants would trigger a catastrophic domino effect throughout the animal kingdom. Herbivores, the plant eaters like cows, kangaroos, and rabbits, would be the first to go. With their food source gone, they would face mass starvation within weeks. Their desperate search for any remaining vegetation would be futile in the encroaching cold and dark. Predators who hunt these animals, like lions, wolves, and eagles, would follow soon after. The entire intricate web of life, built up over millions of years, would unravel with terrifying speed. The silence of the dead winds would soon be matched by the silence of a world without animal calls. Some animals might be able to survive for a little longer. Scavengers would have a brief period of grim abundance, feeding on the bodies of the dead. Creatures adapted to the cold and dark, like certain insects or deep-sea fish, might also hold on for a while. But their time would be limited. As the surface temperatures plummet towards Antarctic levels, very few complex life forms could withstand such extreme conditions. The cold would seep into every burrow and every cave, eventually claiming even the hardiest of survivors. The great extinction event would be swift and merciless, wiping the slate of surface life almost completely clean. But life is a tenacious beast. As mentioned, deep beneath the frozen ocean surface, near volcanic vents spewing heat and chemicals from the Earth's core, entire ecosystems exist without any sunlight at all. In the days and weeks following the Great Darkness, the very air we breathe would begin to change. As the planet cools, the gases in our atmosphere would start to behave differently. The first to go would be water vapor, which would freeze out of the air and fall as snow, leaving the atmosphere incredibly dry. As the temperature continues its nosedive towards minus 73 degrees Celsius, something truly extraordinary would happen. Carbon dioxide, which we breathe out, would begin to freeze directly out of the atmosphere, falling as a fine white powder of dry ice snow. The sky would literally be falling, just not in the way the old story imagined. This process would fundamentally alter our atmosphere. After a few months, the air would be much thinner, composed almost entirely of nitrogen, with a bit of oxygen and argon left over. Eventually, if the Earth continued to cool over centuries, even the oxygen and nitrogen would liquefy and then freeze solid. The sky would become a vacuum. Our planet would be an airless, frozen rock, much like Pluto. All the components that made our world a living, breathing biosphere, the water, the carbon dioxide, the oxygen, would be locked away as layers of ice on the surface, a frozen chemical record of what used to be. The planet itself, now untethered from the sun's gravity, would be hurtling through interstellar space. It would become a rogue planet, a dark wanderer in the vast emptiness between the stars. Its trajectory would be a straight line, carrying it away from the familiar neighborhood of our solar system and into the unknown. It's a lonely thought, isn't it? Our home, our entire world, becoming a cosmic orphan, destined to travel through the cold, dark void for billions of years. It might one day be captured by the gravity of another star, or it might simply drift forever in the eternal night. What would be left of humanity's legacy? Buried deep beneath kilometers of ice, our cities, our monuments, and our creations would be perfectly preserved, frozen in time like insects in amber. Future alien explorers stumbling upon this rogue ice ball billions of years from now might drill down and discover a lost civilization. In the face of such an undeniable, absolute end, how would we as humans react? The first few hours would be defined by pure, unadulterated panic and confusion, but as the dreadful truth dawned, something else might emerge. With no hope of survival, with no future to plan for, what would be the point of conflict or greed? Perhaps in our final days, we would see a strange kind of peace descend upon the world. People would seek out their loved ones, not to find a solution, but simply to be together at the end. Strangers might huddle together for warmth and comfort, sharing stories under the dim light of a flickering fire. Imagine the final conversations. Parents trying to explain to their children what is happening, not with science, but with stories, trying to soothe their fears in a world that has become fundamentally terrifying. Scientists would be broadcasting for as long as they could, not with solutions, but with explanations, trying to satisfy humanity's final, desperate need to understand why. Artists would create one last time, painting by candlelight or singing songs into the growing cold, trying to capture the beautiful, tragic end of everything. There would be an outpouring of love, regret, and acceptance on a scale never before seen. There would be no escape. The wealthiest billionaires in their underground bunkers would only be delaying the inevitable. Their power supplies would eventually fail, and their resources would run out. The cold would be relentless, seeping through even the most advanced insulation. Eventually, the bunkers would become tombs, just like the cities on the surface. This apocalypse would be the great equalizer. It wouldn't matter how much money you had or how much power you wielded. In the end, everyone would face the same cold, dark fate. It's a humbling thought that reduces all of our earthly squabbles to utter insignificance. What would be our last act? Perhaps it would be one of defiance and memory. For as long as power lasted, we might try to beam one final message out into the cosmos. A message in a bottle for a distant, unknown shore. It would contain our music, our art, our science, our history. A final "we were here" shouted into the void. It would be a testament not to our failure to survive, but to our incredible, improbable existence. In our final moments, faced with the ultimate darkness, humanity's last act might be to create one final pinprick of light, a legacy of who we were, sent on a journey through the endless night. So what's the big takeaway from this chilly, cheerful tale? It's that the sun is not just a bright thing in the sky that gives you a nice tan. It is everything. Every bite of food you eat, every breath of air you take, every drop of water you drink, it's all here because of that magnificent ball of fusing hydrogen 150 million kilometers away. The energy in the steak you had for dinner originally came from the grass the cow ate, and the grass got its energy from the sun. The oxygen we breathe is a gift from the plants and plankton that have been soaking up sunshine for billions of years. The sun is the engine, the battery, and the heart of our world. Our relationship with the sun is the most important relationship in our lives, even if we don't think about it. It dictates our days, drives our weather, and powers our entire biosphere. It is so constant, so reliable, that we take it for granted. We complain when it's too hot, or when it's hidden behind clouds, but its steady, unwavering presence is the only reason we are here. Our planet happens to be in the Goldilocks zone, not too hot, not too cold, but just right for liquid water, and therefore, for life as we know it. This perfect positioning is a cosmic accident of unimaginable good fortune. The good news, of course, is that our sun is not going to explode tomorrow. It's a middle-aged, stable star with plenty of fuel left in the tank. It's got a good 5 billion years of steady shining ahead of it before it even begins to enter its red giant phase. So you can rest easy. There's no need to start stockpiling candles just yet. But this thought experiment, this journey into the cold and the dark, serves as a powerful reminder. It forces us to step back and appreciate the incredible, delicate balance that makes our existence possible. It's a cosmic perspective check. So next time you feel the warmth of the sun on your face, take a moment. Stop and think about the incredible journey those photons have made just to get to you. Think about the nuclear furnace raging in the heart of our star, a furnace that has been burning steadily for billions of years to make your life and all life on Earth possible. We are, in the most literal sense, children of the sun. It is our past, our present, and our future. And that, my friends, is a truly great moment in science. So here's to the sun. Long may she shine.